We will continue with more angle proofs using linear pair postulate, angle bisectors, and right angles. And as we work through these, we are going to continue to talk about We the People Eat Pizza and the steps that we can use to help us work through a proof. If you don't have this, you can watch the video that is also online that shows you how to work through it, or you can write it down and follow through it. Okay. We're going to skip the 5-minute check because that is a simple angle addition proof. We're going to move on down to number 2. You can see that these are different from the angle addition proofs because there are some wordy statements. And so we're going to begin by putting in the given, of course. Vx, ray Vx bisects angle WVY, and ray Vy bisects angle XVZ. That's our given. And we want to mark that in our diagram. So if Vx bisects WVY, then these two angles would have to be congruent. Now as you mark it, well, in your diagram, you can also put it in your proof. So step 2, we will actually just say that these two are congruent. So angle WVX is congruent to angle XVY. And the reason that those are congruent is coming from this wordy statement. So we're going to undo this wordy statement and write it mathematically, which we have here. And that will be definition of an angle bisector. Or if the ray bisects the angle, then it creates two congruent angles. Now we have another bisector, Vy. If Vy bisects XVZ, then again, these two angles have to be congruent. Now this one already has a single marking, so we'll mark this one with a matching single marking so that we know that they are congruent. And we will undo this wordy statement also in the same step to say that angle XVY is congruent to angle YVZ. It's the same reason because we're undoing the same word in the same way, so you can put it all in the same step. Okay. Now if we look at this, we've got angle WVX is congruent to XVY, and XVY is congruent to WVZ. So they're both congruent to XVY. And so what we can do actually, since they're both congruent to XVY, then, and they're incongruent, so if the first one's congruent to the second and the second one's congruent to the third, then we use transitive to say the first one must be congruent to the third. Angle WVX is congruent to angle YVZ, and that is your transitive property. So let's just go back and let me talk about what we did here. We put the given in, we undid the wordy statements. We did not have to go to the picture because we were actually ready to move on. We don't have to even do the equals. We can go straight down to here where we know if it's all in congruence and one is congruent to another and the second is congruent to the third, then we can just link them together using a simple transitive step. This does not happen very often where we don't have to convert to equality, but it did happen here because we could use a simple transitive step. Anytime you are going to use angle addition, linear pair postulate, or have things that are equal to numbers, you're going to have to use substitution. So that would require that you convert to equality. Okay? So this one's a little different from the others. Let's move on to 3. 3 has some more wordy statements going on here. This time they're supplementary, and we have one at the beginning and at the end. So I'll show you a little shortcut here, or something that'll be helpful. The given says angle 1 is supplementary to angle 3, so that's our given. There's no way to show that in the diagram, so we don't do anything there. At the end, we have angle 2 is supplementary to angle 3. We don't know the reason yet. So those are both wordy statements. So if you're using this little guide here, we put in our given. Now we want to undo the wordy statements. Now the wordy statements can be undone at the beginning or the end. So we'll undo both of these wordy statements. If angle 1 is supplementary to angle 3, then we know that means that the measure of angle 1 plus the measure of angle 3 must equal 180. And that is because if two angles are supplementary, then they add up to 180 degrees, or the definition of supplementary. Okay. But we're going to wait. We're going to undo this wordy statement at the end in the exact same way. If angle 2 is supplementary to angle 3, then we know the measure of angle 2 plus the measure of angle 3 equals 180. The reason goes at the end of the linking. So to get from 1 to 2, you put the reason in 2. To get from the top, or from the first to the second, you put the reason at the end of the second one. So that's the exact same reason, because it's the same wordy statement, but since one is happening at the beginning, one is happening at the end, we have to put them where they belong. So we have to do it twice. All right. Sometimes when you look at a proof, you can look at where you're coming from and where you're going and ask yourself, how are they different from each other? Some of you can already see it, okay? The other thing you can do is go back to your We the People Eat Pizza and go to the picture. So we did the wordy statements, and now we go to the picture. I don't see any angle addition. We could add these two together, but this one's not marked, so we're not going to be using that. I don't see any linear pair postulates because, again, this angle is not labeled, so we can't do a linear pair here or here. But we do have a couple vertical angles which are congruent. Angle 1 and angle 2 are vertical angles, so we can mark them congruent in the diagram. And lucky for us, that works out because the only difference between line 2 and this line down here is the 1 is gone and the 2 is in its place. So we know we need to say something about 1 and 2, and they're vertical angles, so we know angle 1 is congruent to angle 2. So we write vertical angles are congruent, or it's the vertical angles theorem. Now, how can we get rid of this 1 and put this 2 in its place? And some of you are probably saying substitution. That is exactly right. The only problem is that we can only plug something in for something else. If we're going to use substitution, it's got to be an equality. So we have to convert this to equality so that we can do the substitution step. So just like we converted in the angle addition proofs, we will convert this. Measure of angle 1 equals the measure of angle 2, because if two angles are congruent, then their measures are equal, or the definition of congruent angles. So now we know that 1 and 2 are equal, and we're ready to take the 2 and put it in place of the 1 to get this. And when we take the 2 and we put it in place of the 1, that is called substitution, because we're plugging something in for something else. And then we have our final step here. Good. Let's keep going. At the top, we've got angle ABC is a right angle, and angle 1 is complementary to angle 2 is what we're trying to prove. So angle ABC is a right angle, and we can mark that in the diagram as a right angle. At the end, we can write angle 1 is complementary to angle 2. And we don't mark complementary in a diagram, and we don't mark the prove in the diagram anyway, so that's not going to go anywhere. So we've got our given in. We are going to do the wordy statements now. I'm sorry, we did the wordy statements. No, we're going to do the wordy statements. So we're going to use our definitions to undo these wordy statements. Now, if angle ABC is a right angle, then we know the measure of angle ABC equals 90 degrees, because that is the definition of a right angle. If it is a right angle, then it equals 90 degrees. All right. Working backwards from complementary, if angle 1 is complementary to angle 2, then we know the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So this is the definition of complementary, but remember it goes at the end of the switchover, so it goes down here, definition of complementary. So we did the wordy statements. Wordy statements, check. We go to the picture. Do we see any angle addition, linear pair postulate, or vertical angles are congruent? And right away, I hope you see we've got a whole angle that's made up of two parts. So we've got angle addition. So we're going to say the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. And that is, of course, angle addition. Angle addition postulate specifically. Okay. So one of the things I tell my students is once you undo these wordy statements, you're done. You're not looking at it anymore. Don't cross it out, but you're not going to look at that anymore. So let me cover it up. So this is what we know. We know the measure of angle ABC equals 90 degrees, and we know the measure of angle ABC equals 1 plus 2. So we have two things that are both equal to the same thing. So that brings us to step 4. Equal to the same thing. In this case, they're both equal to not 180 or 90, but to the same angle, which is ABC. So what we can do if they're both equal to ABC is set them equal to each other. And basically what we're doing is we're taking that 1 plus 2 and putting it in place of that ABC right there. Because it's equal to ABC, you can put it in place of ABC, and that's how it got there on the left side. When we put that in place of that, then that is going to be substitution 4. And then we convert it back to a wordy statement. Okay? So anytime you have two things that are equal to the same thing, you get rid of the thing that they're both equal to. Throw it out, set them equal to each other. That's always going to be a substitution step. We're going to stop there and finish up the rest on the next video.